Let's get used to some very basic hypothesis testing terminology. And we will start with what is known as alpha level or alpha risk. And this is the acceptable risk of committing a type 1 error. In other words, incorrectly rejecting the null hypothesis when the null hypothesis is correct. What is an alternative hypothesis? Well, this is one that disagrees, quote unquote, with the null hypothesis. This is known as the alternative hypothesis. And in the majority of cases, this is the one that we as researchers, as Lean Six Sigma practitioners, are aiming to support in case that obviously the null hypothesis is not supported by statistical evidence. So, two types of risk. We have alpha risk, and we're going to talk about beta risk. And we have two types of hypotheses, the null hypothesis associated with the status quo and the alternate or alternative hypothesis. Beta risk or beta level. This is the acceptable level of risk of committing a type 2 error, as we call it. In other words, not rejecting the null hypothesis when the null hypothesis is in fact unsupported by statistical evidence. Conclusion. Conclusion is a statement indicating the level of either sufficient or insufficient evidence regarding, first of all, the level of significance, statistical significance, and whether the original hypothesis statement is either rejected or it is supported. The confidence interval, very important concept, and this is typically a range of values which we hope that will contain the population parameter of interest. So it is often expressed either as a percentage, whereby a population mean lies between an upper and a lower interval. And these two endpoints are calculated by statistical software packages like, for example, Minitab. So Minitab is going to calculate the confidence interval for you based on the data that you input. We can see in our figure an example of what is known as the confidence interval. So we see that we have two endpoints. Within these two endpoints, we have 95% chance that your population mean is going to be between X and Y. And outside of these limits, this is when we typically do not expect the mean of our population to be falling. Confidence level, this term refers to how confident you can be about a conclusion regarding if it is correct or incorrect. So the confidence level is easy to calculate because if you add up the confidence level and the confidence interval, they always add up to 100%. And again, we can see here that the confidence interval is 1 minus the alpha level, the significance level. Usually, depending on the risk appetite of an organization, we can use different confidence levels. The classic one is 5%, but we can use 10% or we can use 1%, depending on what we're investigating and how critical the application is. What is a critical region, which is also known as the rejection region? In the figure, we can see highlighted in blue the rejection region, which means that if the critical value is falling within these areas, then the null hypothesis is rejected. Otherwise, if it is within the white area, this is the non-rejection region of the hypothesis, the null hypothesis, HO. Decision is a statement based on the null hypothesis, so we use typically the expressions of either reject the null hypothesis or fail to reject the null hypothesis. So in statistics and in hypothesis testing, we avoid using the expression we accept the null hypothesis. So if you take a look at the true states of the world, if you make a decision that the null hypothesis is false, but actually the null hypothesis is rejected, then this is the correct decision. Otherwise, you're committing a type 2 error. If the null hypothesis is true and you reject the null hypothesis, then you commit a type 1 error, as we call it. And again, here in the figure, we can see the correspondence between either rejecting or failing to reject the null hypothesis and the reality of either the null hypothesis being true or the null hypothesis being false. So if the null hypothesis is true and we reject it, then we commit a type 1 error, or alpha error, as we call it. If the null hypothesis is false and we fail to reject it, then this is the correct decision. And now let's talk a little bit about right-tail tests and left-tail tests. A left-tail test is the case where the alternative hypothesis contains the less than inequality symbol. So in this case, we say that we're dealing with the left-tailed hypothesis test. The null hypothesis is typically expressed as H0 or HO, and this is basically the statement that we're trying to disprove in case that the null hypothesis is not supported by statistical evidence. It represents the status quo, so the null hypothesis always states that there is no statistically significant difference between before and after, and any difference is purely due to chance, due to common cause variation. It is the assumption that the experimental results are due to chance alone, and nothing else, such as special causal variation, has influenced the test results. Another interesting term is the term pooled, which is the opposite of the term unpooled. So the term pooling refers to the way in which the standard error is estimated when we're calculating terms for a hypothesis test. So in the pooled version, the two proportions are averaged and only one proportion is used in order to estimate the standard error. Now, there are different schools of thought. So if we look at the ASQ, the American Society of Quality, and the Villanova University and most of other organizations, they favor the pooled type of calculation. But if you take a look at IASSC, the International Association of Six Sigma Certification, the syllabus of which we're following, they are generally in favor for unpooled. P stands for probability. So the p-value is the probability of getting a test statistic that is at least as extreme as the one found from the sample data. So p is typically expressed as a decimal, for example, 0.05, or as a percentage, like 5%, or as a fraction, for example, 5 divided by 100. It is a crucial element in hypothesis testing, and this is a value that is calculated by the statistical software package like Minitab, Sigma Excel, Statistica, etc. And it is always a number between 0 and 1, and gauges the probability that random fluctuations caused any data that might cause you to reject the null hypothesis. This value is calculated by running test results, and if it is lower than your alpha level, then you fail to accept the null hypothesis. If the p-value is higher than the alpha level, then you fail to reject the null hypothesis. As we said, we try to avoid using the term "we accept the null hypothesis." Right-tailed test. Well, if the alternative hypothesis, HA, contains the greater than inequality symbol, then the hypothesis test is a right-tailed test. And we can see example in the figure that is displayed on the slide. Usually, we're hoping that we will fail to accept the null hypothesis because that means that our efforts in making a change to improve a business process have been unsuccessful. Significance level or alpha level, this is a topic that we covered a little bit earlier. Here it is rephrased in a slightly different way. And regarding the test statistic, it is a sample value that we use to decide whether to reject or fail to reject the null hypothesis. Two-tailed test. This is one with two rejection regions. So if the null hypothesis has an equal sign, then this is a two-tailed test. So we can use the test statistic in order to reject the null hypothesis if the test statistic is either too large or too small. In other words, if it falls into one of the regions highlighted in red. So this concludes all the basic terminology associated with hypothesis testing.